Today we're going to create a Linux-based DNS server, and it's going to be a secondary DNS that front ends an Active Directory domain controller and its DNS. Why and how? Coming up next.
Welcome to Tech Topics brought to you by Cybervenger. We help keep small businesses stay protected and compliant with cutting-edge cybersecurity and IT solutions.
Okay, so first, what? DNS, Domain Name Service. It is the naming engine that pretty much everything in all of IT uses, particularly the internet, but not just the internet. Go to www.cybervenger.com. You're not going there, you're getting a IP address from DNS that takes you to where our web server actually is. www is called the host record side. The fully qualified domain name, www.cybervenger.com, is the whole thing. All those records, www, ftp, mail, all of those are just records, and something needs to contain those records. That's DNS. Active Directory is a well-known Windows login database. If you got 50 machines on your network, you're probably running Active Directory if they're all Windows, and Windows workstations will be connecting into an Active Directory domain controller so that you can log in as any user on any given workstation and still use the same username and password. Active Directory uses DNS as a back end. It is critical to Active Directory's functioning. What a lot of companies will do is they'll have the domain controller, and then they'll have DNS services on that domain controller, kind of fused into one. In fact, the default install has that set up. And the idea being that all the workstations have their DNS names registered, and the servers do, so you can go to fileserver.ad.cybervenger.com, for example, and connect to that file server. Or whatever. It's nice sometimes, though, to be able to publish those records to maybe a less trusted network. Let's say you have a public Wi-Fi or a DMZ, and you have Active Directory. Very important, because if you break an Active Directory, you can log in anywhere. You do not want your Active Directory compromised. You could redirect just port 53 for the DNS to your domain controller that's running DNS, or you could stick DNS in another Windows host, but that's, more licensing, and it's not as fun as what we're about to do. Or you can take another DNS server. In this case, we're going to use Ubuntu Linux, and we're going to put bind9, which is the service that does DNS, and we use it as a secondary DNS server. Secondary meaning it's going to cache all the entries of the production one. Production one being our Active Directory domain controller. So it's going to have a pinhole back there. It's going to be the DNS outside of our little firewall, little segment, be it published out to the internet, be it just published to a DMZ or a public Wi-Fi or something like that. Doesn't matter. But that's the general use case. Now with Active Directory, there's two zones. A zone is the domain name, like cybervenger.com, or maybe for Active Directory, ad.cybervenger.com, or whatever your domain is in your case. But there is a second one, _MSTDC, and then your domain name. And that's the Active Directory. You don't necessarily want to replicate that outside unless you're trying to have Windows clients authenticate in, but we're not addressing that eventuality today. We just want to be able to publish our own records for cybervenger.com, maybe like intranet.cybervenger.com, or portal or payroll or FTP, whatever, cybervenger.com that we don't want necessarily to set public records for. Or maybe we are. Maybe we're publishing our own DNS server and we just want it to be linked to the Active Directory somehow, but not completely. So we're going to first load up a Ubuntu Linux box, and we're going to do that off camera because that's kind of out of scope here. And then we're going to show you how to load DNS services specifically and then point them to another DNS server. Coming up next here. Okay, so here is our new DNS server. It's DNS3. It is just a simple Ubuntu container. I already set up all the requisite stuff. Now we're going to actually go through the install of bind9 and other related changes. So here we go. First things we're going to do is we're going to apt install curl vim ufw. Make sure we have all those things in there. Yep. Okay, next we're going to type hostname CTL, and we're going to set our hostname to DNS03, or just DNS3. Okay, Okay, so there's another service called systemd resolved that tends to run in Ubuntu. We're going to turn that off. Let's just see if it's running first. So here's command systemctl status systemd resolved. We're just going to see if it is in fact running by checking for the status. That's what systemctl does. It's kind of the equivalent of a Windows services.msc. Yeah, look at that. We got it running, so we're going to stop that. First thing we're going to do is we're going to disable the service. So there is disabled. Okay, that's done. Then we're going to trash the existing resolve.conf file. Okay, and once we do that, we're going to generate a new one. The lazy script way here. Yeah, and if you notice, we're just doing typical Google name servers. And it's just printing this message and redirecting straight to that file. We could use nano if we wanted to. I felt like being lazy. Okay, now that's kind of cleaned out here. We're going to do the actual install. So apt is our install. And if you see apt install bind 9 utils, and DNS utils, get all three of those in there. And I'll close that puppy up. Okay, that finished up. Now we want to turn the service on. Now we got that error, so I'm going to do systemctl status bind 9 and just see if it's actually running. All right, well, it says that's active and running here. So we're going to go on ahead and pretend we didn't see that error. I'm not quite sure what that was all about. And then we'll test and see if it works. If not, well, we'll fix it. We're still going to have to set up all of our files, so I'm not too worried about that right now. So moving on. All right, now we want to enable our settings or configure our settings. Nano or Vim. I'm kind of a fan of Nano lately. And here's the config file. What we want to do is make sure that recursion is turned on. Recursion is important because basically what a DNS server is it goes out and gets, here's our cache directory. It's going to cache things it finds, and it's going to find information for you and then store it. That's what the recursion does. We don't have that directive in here, so we're going to have to add it. First things first, we got our forwarders here, so let's turn them on. These little backslash things, those are comments. So I'm just going to be lazy and just put 8.8.8.8. We could do more if we wanted to. We just separate them by commas. We're also going to need turn recursion on. I think I'll put that right. Yeah, it doesn't actually have that in the comments, which is a little annoying. We'll have to paste it in. Actually, before I even paste that in, I'm going to put our IP address in here so we can listen to all of our interfaces. All right, and then I'm going to set our other options here. I just paste an entire block to speed things up a little. We'll go that in there. Line that up so it looks reasonable. All right, so recursion. That lets us go to resolve other DNS servers. Like if you want to use it for your... how do I say this? If you're using the DNS server just to be authoritative out on the internet, you don't need to allow recursion. But if you want your clients to use this DNS server to resolve the internet, then you need to turn on recursion, which is what we're going to do. We're going to allow recursion from only this network and of course, localhost. And we also allow queries from this network. We're pretending this is a DMZ. If it were, you can do everything if you wanted to instead of just that. Pretty much if you don't specify allow, it grants everything. So now we're going to Control-X, save it, and we're going to attempt to verify that this config makes sense. Unknown option. It does not like that. What is it? Let's take a look at this. So forwarders. Yeah, that should be it. Oh, it's got a... That probably shouldn't be there. Think. Actually, no. Oh, my problem is I didn't comment this out or undo the commenting. That's what we need. There we go. All right. And then we are going to nano and edit this. We already have a config in here, but I'm going to paste more stuff. All right, so I got paste my extra stuff here. There we go. This is a template I got off the internet, but let's make it a little personalized. Pretend we're Cyber Vendor here. You can, of course, put your thing in there. I don't need to let just DB. That's not necessary. I do want these to match, though. Make sure you don't have any typos or spelling errors. All right, so this is defining the zone to which we're going to be secondary for, and then where that zone file is at. Okay. That config was actually wrong. That is what you would set up if you wanted to be the master, and we want to be a secondary. So that's not, it's all master, and like that's not right. Here we go. Forward. This is what we want. These are our forwarders, and type forwarding, and this is going to be our Cyber Vendor. Okay, that's what we're looking for at the config. We could also add another zone if we want more than one. Okay, so there, I got that in now as another forwarding. If you notice, underscore MSDSC, that is for domain controller stuff. So if I wanted clients to be able to log into the domain, and this is the only DNS server they have available, then that would do that. But that kind of doesn't work because they can't reach the domain controller. So this probably wouldn't be all that useful unless maybe you had a read-only domain controller or something. All right, now we're going to save this here. And we're going to restart it and test it. Look at that. Looks like we're running good. All right. First thing you do to test it, dig is a DNS command for Linux. Using itself here. And at 127.0.0.1. That, yep, use yourself. How about yahoo.com? What do we got? Boom. Look at that. It found stuff. Hooray. Okay, that's good. So you can test your resolution, make sure it works. Then you can point your workstations here and test it again. That's really all it is to get the basic functionality working. But of course, we're a cybersecurity place, so nothing would be complete if we didn't also at least set up a firewall, right? So here we're going to do that. And I'm going to just paste a whole bunch of commands all at once. There we go. Yep. All right. So to review that, we are, there we go. We're denying everything by default. We're allow outgoing by default. We are allowing from our lab network for UDP and TCP for 4053. I couldn't find out, all the examples I found do mention TCP. I haven't seen an explanation as to why. Really, DNS is supposed to be UDP. I'm guessing this is for updates, but this is a secondary DNS, so we might not even need that. This is kind of sort of optional. Then we got to turn it on, check the status, and the rest is history. The rest you saw fly by. And now we have our status. It shows it's allowing it in. Our SSH connection is still connected. I don't see that in. I did not add it in. So yeah, you may want to actually, it'll maintain a session if you accidentally lock yourself out. It won't kick you out. So what you want to do is UFW allow from, oh, hang on. Okay, I think that's it. Hang on. Ah, there we go. Okay, allow SSH. So there we go. So my SSH is still allowed. So if I disconnect them, I'm still there. And that's it. That's our firewall. Now there's other things you can add. You can add things like fail to ban. You can stick an EDR on here or an RMM tool or other things to harden this up. This is just basic security. This is not really what I would call hardened at this point. I may probably do another video on how to harden Linux. Get some tips there for people. But this is already pretty long, so that's DNS in a nutshell. So that really is just all you got to do to set up a basic secondary Linux DNS server. You can put it in front of a Windows DNS to help front Active Directory or other internal names, nodes. It is going to allow you to put this machine out in front of an untrusted network like the internet or DMZ or maybe your public Wi-Fi or something like that, and prevent the more sensitive things like your domain controllers from being directly accessed. It's kind of a partitioning, for a proxy, if you will. It's not the end of security, it's the beginning. You would want to then try and harden the Linux operating system, kind of out of scope of this video, so we're going to try and do another video later. But you can do things just to kind of sum it up, things like add fail to ban, which is a program that'll lock out, do intruder lockout for fail SSH attempts, things like that. You would probably want to put an EDR like Sentinel-1 or something on there. You would probably want some kind of logging system like AdLumen or some kind of centralized logging, some kind of SIM system to track that as well. But we can do another video on that another day. This is a good primer, get you started. And I hope you all found that video helpful, and we'll see you in the next one.
Thanks for watching. We hope this video has provided valuable information to you. Be sure to share this video with other small business owners to spread the word about the importance of cybersecurity. As always, don't forget to like and subscribe for more videos like this. If you want more information about cybersecurity, visit us at www.cybervenger.com.